right, for everyone that's here, ready and ready, pay attention. So let's go, class.
Yes.
Thank you, Sophia. What's up? Let's do forward. Okay, there it is. All right, interpreting the derivative as a rate of change. Surface area S in square meters of a balloon expanding as a function of time in t seconds according to the function S is equal to S of t, which is equal to 5t squared. Find the rate of change of the surface area of the balloon with respect to time. What are the units of S prime of t? So, if I want to find the rate, okay, I want to find the slope. That's what it is. The rate is just the slope. And so that means I don't want to actually try and plug it in. I can't use the C one, right? I have to use that x plus h. Okay, so I'm going to plug that in. So if this is my function, I'm going to find the limit as h approaches 0. I get 5 quantity x plus h closed square minus 5 x squared all over h. You notice I changed my t's to x's for the use of my formula. All right, expand. So I expand that, I get 5 quantity x squared plus 2xh plus h squared minus 5x squared, again, all over h. As I distribute, I'm going to get 5x squared plus 10xh plus 5h squared minus 5x squared, again, all over h. What's supposed to happen around her? These things right here are supposed to cancel. And I'm still left with an h, right? Everything has an h. So I'm going to factor that out. I'm going to have h quantity 10x plus 5h over h. What's going to happen to those happy little h's? Die, thanks. All right, so again, we are taking the limit as h approaches 0. 10x. Now, what does that mean? In this case, this is going to represent my s prime of t is 10x. What does that mean? It's going to give me the slope at any given point, right? Slope at any given point. Now, next part right here, it says find the rate of change of surface area with respect to time. What are the units of this? So, what are the units going to be? Square meters over seconds? Yeah. So it's actually going to be meters square per second. So whenever we plug something into this, I'm going to have a rate of that. It's a positive rate, isn't it? So over the course of time, what is happening to this balloon? It's getting bigger. It's inflating, right? So the area of this is getting larger as it keeps getting bigger, right? Over time. Does that make sense? Hopefully, maybe. Okay. All right. Graphing functions and its derivatives. Find f prime if f is equal to x cubed minus 1. Then graph y equals f of x, y equals f prime of x on the same set of coordinates. Now, the blue one right here is going to be my x cubed. It is x cubed. So by graphing it, there's certain things that I understand. Right here, what do I know about the slope right there at that point? It is 0. Very good. It has a slope of 0. So that has a slope of 0 right there. So I know that my derivative, this is a graph of the derivative. So that means that it's going to be 0 when x is 0. So my coordinate is going to look like this. So it's going to be, wow, that is weird. Okay, so this is x, and this is f prime of x. So when x is 0, my slope, my slope is 0. So it's touching right here on the y-axis, right? Yes? Now, what can you tell me about the slope over here on this side? Why is this red? This is supposed to be blue. Starting acting up. Nope. How do you read in math?
Well, I mean, it's increasing, but over the slope is decreasing as you get closer to 0, or it's increasing at a decreasing rate. You know what I'm saying? Like it's increasing, but it's increasing less and less.
Yeah, but it's still, the slope is,
increasing.
it's increasing. It's positive. Okay, so now to show that over here, I'm showing that all these numbers over here, what can you tell me about all these numbers over here? All those numbers, the y values are positive. These are all positive. So these are all positive. So that means that there is a positive slope here, right? So that means that this is an accurate representation of my positive slopes, right? So way over here, is that a steeper slope than over here?
Yes.
Okay, so this is a higher number here than it is over here, isn't it? Okay, so now let's go to the right side of this. What can you tell me about these slopes right here? It's positive slopes. Again, it's increasing. It's still going up. So it's positive slopes. That means the numbers, as it comes down to 0, I get positive slope up to 0 here. I get 0 slope. But then again, it goes positive again. So it starts going back up here. So again, I now have more positive. And so, like you were trying to say, it's increasing at an increasing rate, right? So yes, it is small. So right here, so my slope here, according to this, should be 15. Wherever that ends up being. I don't know, I'm not very good at this. So whatever 2 is, I think it's 2. Or wherever that comes out to be. Anyway.
Would you be able to find the tangent line at 0 because it wouldn't be able to just touch it, it would have to cross?
So the tangent line at 0 is? 0. Or Which one are we talking about? Like this one right here?
For the FX. Because I thought tangent lines couldn't cross the line.
Oh, it's going to, but it's touching at a single point. So that means that it's, even though it is going to go through right here, it's, yeah, still going to touch. But yeah, it is going to touch it at a single point. So the idea that it only touches it and only at one place, how would that work on a sine wave? You would have to touch multiple times, right? Yeah. So, but it's supposed to be that it touches at a single point.
Well, technically, couldn't something also touch at a single point and definitely not the tangent line if it just cut through it? That would still touch a single point, but it wouldn't be a tangent line.
But the normal has to be perpendicular to that. So right here, this has a slope of 0, right? That has a slope of 0. But perpendicular, my normal line would go this way, which would be perpendicular to the tangent. So we could have other types of lines right there, but the tangent line, definition of tangent, okay, it is the slope at that point. So yes, it can, depending on the wonkiness of my line, touch it multiple times. But it's, yeah, it's touching at a single point right there. All right, good question though. All right, here's all the work. I actually, since my drawing skills suck, I threw this in here for your slides so you could actually see what it is. So right here, doing the math for this one right here, we get that the slope is 12 at that point right there when x is -2. So when x is -2, my graph of my derivative is -2 comma 12. So yeah, that right there is usually a problem a lot of people have when you're identifying. This is not y values, this is y prime values. So it's x values and y prime values. Okay. All right.
They always have to trade below.
Huh?
They're always have to trade below, right? For that, because that was a huge step.
Yeah, it's a pattern. It should be. All right, use the graph of the function here to show f prime. So you guys are going to do this now on this one. do we pick up first?
I was just thinking, like, for some reason I'm trying to go like point by point and like decide where the connect.
Oh, let's start off with, what did I start with? What zero?
Because it's asking us for the graph of F.
Yeah, but I think our last one kind of got you on there. Where is the slope zero?
Oh, yeah.
Right here, right? Slope zero is here. Where else is slope zero? Okay. So that means that my f prime, which I'm going to change colors for this. Actually, no, let me stay black. F prime, so that means it's going to, my f prime is going to cross right there, and it's also going to right there. Now, looking to the left of -2, what is f doing to the left side of -2? Okay, it's increasing, right? Okay, so it's going up there, right? So that means that it should be something like this.
And we can assume that it would be a parabola because that looks like
It's going to be. All right. Now let's identify to the right side of 3/2. To the right side of 3/2, what's it doing? It's increasing, right? So it should be, the slope over there is all positive, isn't it?
I had the same idea, I swear. It was like lightly sketched out.
Okay. Now, in between -2 and +3/2, all that slope is going down, isn't it? So my graph of y prime, which this is actually a y prime here, all of it is a negative, isn't it? Down to some point up to there. Now, this right here is also a 0, is referred to as an inflection point. It's where it's going to change. It's changing from, it is decreasing at a increasing rate, right? And then it changes from decreasing at a decreasing rate. So it goes to an increasing down to a decreasing.
Wouldn't it not technically be at 0 though? Wouldn't it be like a little bit far left of 0?
Why?
Because the graph,
This says it's going through at 0, 0.
but that doesn't necessarily mean it's an inflection point right there because
Yeah, it's somewhere there. I know what you're saying. That this is supposed to be symmetrical. If it is, then it's somewhere over here.
Right there.
So, but we don't have the function, so we don't really know. All right. So, you had the great idea. It should be 1 degree less. The graph of function f is the blue one. That one right there, it looks like a 3rd degree. It's an x cubed. I know it starts down, goes up, comes over, and back all the way up. It only has one curve in it, so that it's going to be an x cubed. It could be an x to the 5th, but usually x to the 5th, you actually have a little bit more wonkiness right in the middle, but that's an x cubed. So therefore, the degree should be 1 less. So therefore, the degree of my derivative, the black line here, is going to be an x squared. The shape is an x squared there. Okay. All right. So, given the piecewise function, define the function here. So, let's find the derivative of both sides. So the derivative of the left side, and it's asking for to go in between those two. So that's going to give me the limit as h approaches 0, negative 2x plus h close squared plus 4 minus quantity negative 2x squared plus 4 all over h. Doing the math, negative 2 x squared plus 2xh plus h squared plus 4, and then distribute, so plus 2x squared minus 4. Yeah. And all this is over h, but I'm going to distribute. So negative 2x squared plus, nope, minus 4xh minus 2h squared plus 4 plus 2x squared minus 4. And again, all this is over my h. And let's see, my negative 2x squared and my positive 2x squared, my negative 4, my positive 4. So I should have that h's. So I get a h quantity negative 4x minus 2h over h. Then take the limit as h approaches 0. Those things go away. And I'm left with negative 4x. All right, I need to do the other side also. So kind of ran out of board here, so I'm going to another page for that one. So x squared plus 1. Limit as h approaches 0, we have x plus h squared plus 1 minus parentheses x squared plus 1 over h. I get x squared plus 2xh plus h squared minus x squared minus 1. X squareds. I should have plus 1 here, don't I? Oh, no, I don't. That's what I didn't do. Gotta have plus 1 right there from this right here. I did not write that. So there's my plus 1, minus 1, and I have h quantity of that's positive 2x plus h. And that is the limit as h approaches 0. We get my f prime of this side is 2x. Now going to the words of what it said determine if f prime of 1 exists. So the other one was it negative 4x? So if I plug in both of them, I'm going to get a slope. So f prime of, was it negative 1 or 1? Positive 1. Okay. F prime of positive 1 for this one here is going to give me a negative 4. And of the other one right here is going to give me a positive 2. So what that means is that my slope is going to come down. So it is a negative 4 on the left side. So it's going down pretty steep. And then at 1, it also changes to be like this. So this is going to be a pointy point. When I look at this, my slopes are different. So at that point 1, I have 2 different slopes. So what this is, it's going to be a, I gotta pull up the thing. Where's my calculator? There's a computer update that messed up everything, and so now my board's all glitchy and nothing likes me. And I don't know why, but my navigation keeps turning on. So, all right, so let's go to our functions, and right here, I'm gonna have piecewise. What was it? It was 2x squared?
Negative 2x squared.
Okay, so negative 2x squared plus 4, and that's when x is what?
Lesser than 1.
Less than 1?
Yeah.
Okay, so control here, and plug in this other one, and it was x squared
Plus 1. And that's for when x is greater than or equal to 1.
like that?
Yep.
Okay. All right, so looking at this, now, that right there, that is a pointy point right there. So I cannot take a derivative at that point. So you cannot take a derivative at a pointy point like that.
But if it's curved, it's okay.
Yeah. So if it curves, it's okay. Pointy point. So think of it like this. Tangent line. Can I balance a tangent line on there? No, because on that, it's touching at a single point right there. Yeah, but it's going to rock on there, right? So if you're trying to balance something, it doesn't balance on there. Does that make sense now? So yeah, so that's the reason why I can't. Is that a question? No? Faye? No?
Oh, no, sorry.
Okay. All right, so I think I'm going to leave you people here today. And No, the people online that are actually following and listening. So, so there it is right there. Okay, it does not exist, and it is a corner or pointy point right there. That's how I always refer to it.
It's pointy point. If we put pointy point on the AP test, will we get credit?
You have to say corner, but I just try to describe it best what it looks like, and you can see what it is.